Dear students, today we will discuss Introduction to Arithmetic Progressions. Here we have some lists of numbers. Each of the numbers in the list is called a term. So in the first series of numbers, you see the terms are 6, 7, 8, 9 and 10 and so on. Now each term is obtained by adding 1 to the preceding terms. Next one we have 80, 50, 20, minus 10 and so on. So how are we getting the terms? By subtracting 30 from each term, we are getting the successive terms. Or we can say that we are adding minus 30 to the preceding one to get the successive terms. That means when you suppose the first term is 80, so when you add minus 30 to it, you get 50. Again 50, when you add minus 30 to it, you get 20. Thus we are getting the terms. Next one, minus 3, minus 2, minus 1, 0. So how are we getting the successive terms? By adding 1 to the preceding term. Then next we have all the terms are 7. That means each term is obtained by adding or subtracting 0 to the term preceding it. Then we have minus 1.5, minus 2.5, minus 3.5. So here what are we doing? We are adding minus 1 to each term to get the successive terms. So what we have noticed here, that we get the successive terms by adding a fixed number to the preceding terms. Such a list of numbers is said to form an AP or arithmetic progression. So what is arithmetic progression? It is a list of numbers in which each term is obtained by adding a fixed number to the preceding term except the first term. What does it mean? The first one, you see, we are adding 1 to each term to get the successive terms. So that 1 is fixed. In the second case, we are adding minus 30. So each term is added, minus 30 is added to each term to get the successive terms. So thus we can see that in all the cases we are adding a fixed term, and that fixed term is known as D, that is called common difference. Common difference, that is represented by the letter D. So this D can be positive or 0 or negative. Now in the first case you see 6, 7, 8, 9, 10 and so on. Here D is 1 plus 1. So when D is positive, we say that the AP is increasing. When D is negative, that means you can see case number 2, the AP is decreasing. And in list number 4 you see D is 0 here. So we can say that the AP is constant. Next, now suppose we have the terms as, like, first term we consider as A1, second term as A2 and the nth term as AN. So we can write the AP as A1, A2, A3 up to AN. This is the way to write an AP. Now since these are the terms of the AP, so the difference between a term and with the difference between two terms, that means the term and with its preceding one is always constant. So A2 minus A1 equal to A3 minus A2 equal to A4 minus A3 equal to AN minus AN minus 1. The term preceding AN will be AN minus 1. So that is, these are constants. All the differences will be constant, and that is known as common difference. So thus we can write the general form as A then a plus d, we are adding d to a to get the next number, next term, and then again we are adding d to 8 plus d. So when you add one more d, it becomes a plus 2d. Then we get a plus 2d as the third term. We again add d to the third term to get this, and thus we are getting the successive terms. So what will be the nth term then? A plus n minus 1 d. Now why did I write this one? So see here, the first term is a. The second term you are getting by adding d to it. That means a plus 1d. Second term you are getting a plus 1d. So what will be the third term then? First term is a plus 0 into d. Then the second term is a plus 1 into d. We are adding d to it. 0 into d means actually nothing. So when you add d to it, you are getting the second term. When we say second term, this is your 1. Coefficient of d is 1. Then a third term is a plus another d will come. So 2d. So third term is 2 here. That means 1 less than 3. So in that way, when we follow like this, so we get the nth term as a plus n minus 1 into d, where a is the first term and d is the common difference. Now let us discuss finite AP and infinite AP. What is finite AP? Now, when there are only a limited number of terms in an AP, then we say that it is a finite AP. Now the terms are, here we have written, for example, 253, 243, 233, it is a decreasing AP, and the last term is 203. In finite AP, there will be infinitely many terms in the AP. Now what is the difference? In a finite AP, we will always have the last term. That can be also represented as L, last term. And in an infinite AP, there is no last term. The sequence goes on, increasing or decreasing, or it may remain constant. Now, if we have A, B, C as terms of an AP, suppose we have 3 terms in an AP, A, B, C, then we can write it as, since these are the terms of AP, so what can we say? B minus A is common difference, D will be equal to C minus B, because the common difference is same throughout. So B minus A equal to C minus B. And then you bring B this side, it gives you 2B equal to A plus C, B equal to A plus C by 2. This we can use while solving some sort of questions. Now next we will discuss the solutions of exercise 5.1, and then in our next class we will talk about nth term of an AP and also how to find out the sum of first n terms. Thank you.